Assalamualaikum warahmatullahi wabarakatuh. My name is SYED ILHAM from course R140 System Electronic. So today I'll be presenting about like 5 active filters. So let's learn about active filters. So for filters we actually have two types of filters which we call active filter and passive filter. So for passive filter it's just a circuit with inductor and capacitor. It does not require any external power source, and it does not use a operational amplifier. But for active filters, it consists of resistors and capacitors, and also a operational amplifier to create the filter. So today we'll be looking at low pass filters and high pass filters. So this is the circuit for a low pass filter, and this is a circuit for high pass filter. So okay, so this is we'll be doing a simulation. So the values of resistor and capacitor is already given to us from the lab sheet, from the lab module. So we just have to calculate the frequency, cut-off frequency. So what we'll be experimenting today is what happened to the gain, to the voltage gain before and after uh, uh, no, not before and after, is more like if it is less than the frequency cutoff, what will happen to the voltage gain, and if it is more than the frequency cutoff, what will happen to the voltage gain. So let's try with a Salenki low pass filter. So okay, this is a Salenki low pass filter. This is a second order Salenki low pass filter. We call it as a second order because we have two RC sections. To simplify, we can just count how many capacitors are in this circuit. So like here we have two. So actually the RC section is here. After this resistor, it meets this capacitor. This is one RC section. So this is the other RC section. So we call it a second order, or we can call it a two-pole Salenki low pass filter. So to do this, we have to refer to the table that so this is the frequency cutoff we calculated. So we test off what happens. This is less than the frequency cutoff. So what will happen to the frequency to the voltage gain? So as you can see, I put it less than. So after simulating, we can see that the voltage in and the voltage out is the same value, 2 volts. The voltage in that we give is 1 volt Vp, but the frequency is based on the table we calculated. So we get the voltage gain is 1. So since voltage gain is voltage out over voltage in, so we get 2 volts over 2 volts, so we get 1. So okay, so afterwards let's try 14.2k, the highest. So as you can see, the voltage out is uh, less than the voltage in, which means that the voltage gain is less than 1. The the voltage gain is less than 1 when it is more than the cutoff frequency for low pass filter. So after we test it out with different uh, frequencies, we test out with different frequencies to to make it easier for us to plot a graph, which is the voltage gain versus the frequency graph. So we will get the voltage gain versus frequency graph like this. So we get the voltage gain is stable. uh, a quick info, the voltage gain here is in dB, so we had to calculate from the gain we calculated to dB. So as you can see, the graph is stable when the frequency is less than the frequency cutoff. So it means the low the low frequency was able to gain a stable voltage gain. After the frequency is more than the frequency cutoff, the the voltage gain begins to decrease and lose its stability. So okay, next will be looking at high pass active filter. So for high pass active filter, which is supposed to be the same as a low pass filter, but okay, I'll show you. So this is high pass filter. So for low pass filter, we start off with resistor, then capacitor. So for high pass filter, it is inverted. So we need capacitor first, then resistor. That's the difference between high pass filter and low pass filter. So for high pass filter, so we have a table too, which we calculated. The frequency cutoff is different because the value of the resistor and capacitor given is different. So we start off with low frequency. So as you can see, the output is the voltage is very small in when the frequency is lower than frequency cutoff. So it is inverted with the low pass filter. Low pass filter, when the frequency is lower than the frequency cutoff, the voltage out is similar to the voltage in, and we get a stable voltage gain. For high pass filter, the lower if the frequency is lower than the cutoff, uh, the the output will become small. So it means that the voltage gain is less than 1. So if we change this to a high frequency, if we change it to a higher than the voltage cutoff, so let's try okay, 56.5 kilo. So 56.5 kilo is more than the frequency cutoff. As you can see, the voltage output is almost similar to the voltage input. Even now, it is like joined together with the voltage input because the value is very close. That's why you can see, like, see there's still green here. It means that there's still a voltage output which is very similar to the voltage in. So we get a 2 volt voltage out, which means we have a gain of 1, since voltage out over voltage in is equal to the gain. So similar to the low pass filter, we tried different frequencies to make it easier for us to plot the voltage gain versus frequency graph. So this one is opposite to the low pass filter. So for low pass filter, it is stable during the low frequency stage. So for high pass filter, it's stable after it reaches after it is more than the frequency cutoff. So see, this is not stable from here to it will become stable after it has reached its yeah, after it is more than the frequency cutoff. So here is the stable part. So doing 4.5 kilo hertz of frequency. So so before I end, each of the RC section. So okay, let's say we have two poles of uh, two second order silent key. So as you know, second order silent key has two poles. So one pole is equal to negative 20 dB. So if we have two poles, it means we have 40 dB of uh 40 dB per decade for the graph. So I think that's all for my presentation on my understanding on lab 5 active filters. So thank you very much for watching my video.